Ladies and gentlemen, it's time. I'm so excited to show you today something incredible. Down through our ancestral tapestry of the ancient Greeks, we have been given a gift. A distant whispering of solemn remembrance. This method of solving triangles is so precise, so beautiful, so simple, so elegant, so powerful, that almost every single doctrine in the world benefits from these exact equations we will write today. Ladies and gentlemen, I am talking about trigonometry. Today we're going to be looking at the review for trig. Alrighty, don't look at that. Down here at the bottom, we're going to look at the review for trig. I'm not going to fully explain totally in depth. I think we're kind of on the same page here. Let me take this crown off. Trigonometry, I know I'm being dramatic, but it genuinely is the triangle killer. This is, like I said in class, this is the wooden stake to the vampire. Alrighty, you guys remember these in English 1, right? Like, what are they called? Syllogisms. Trig is two triangles. Okay, and then you have to come up with your own down here. For me, if you ask me this, trig is the triangles, I would say a stake to a vampire. That's right. I would say this is the silver bullet. I don't know if I can write silver bullet on a school funded account, but I'm not. So I'm not going to. But I'm pretty sure that's werewolves, right? Werewolves, and yeah, just you know what kills them. All right, fill it in. So Jade isn't Littleman. What doesn't a silver bullet kill? Can we just talk about that? A werewolf is weak to silver bullets, bro. So am I. Guess I'm a werewolf, right? Anyways, what we'll say for these particular functions, what was passed down to us by the ancient Greeks and the Egyptians is SOHCAHTOA. Alrighty? Now, SOHCAHTOA is just a mnemonic. That's P-N-E-U-M, mnemonic? That's a mnemonic. Okay? It means it just helps us remember. Okay? This is not the actual functions. The actual functions are sine, cosine, and tangent. These are their shortened names because who in their right mind is going to write sine, cosine, and tangent every single time? All right? So here, for example, the cosine of D, we can look to SOHCAHTOA to see that the cosine of D is given by the adjacent divided by the hypotenuse. That's what this says. Okay? So if I look at and I don't really love this notation. If I had to rewrite this, I would say the cosine of the angle D. Because really the cosine is a function that takes in angles and gives out ratios. In this case, the ratio is the adjacent divided by the hypotenuse. So if I look at the angle at D, the adjacent side, the closest side, is here, and the hypotenuse is here. So the fraction I would write for the cosine of the angle D is 8 divided by 17. Boom, box it in. Okay? I know this can be confusing because we didn't actually solve anything. We just wrote something out. That's because there's nothing to solve in this triangle. We already know everything. This triangle is just here purely theoretically to see how the trig functions work, right? We're just using the definition of the trig function to get a number. We haven't actually solved for anything. Notice we already know everything about this triangle. And actually, let's check the key real quick and see if it's even a right triangle. 8 squared plus 15 squared. Not that one. Never that one. Whoa. Technology. Am I right? And we get this 289. We'll take the square root of 289. And sure enough, we get 17. That is a Pythagorean triple. Well, look at that. So that really is a right triangle. Beautiful. Anyway, so for tangent of f, We'll do the same thing. Tangent is opposite over adjacent. So we'll look opposite across from the angle. Oh, sorry, wait. Now, I got to be careful. We're at the angle F now. So opposite angle F is 8. Alrighty? And then the adjacent is 15. So in this case, it's 8 over 15. And then here, the sine of the angle F, if we're looking back at F again, that's opposite over hypotenuse. So notice that the trig functions, they depend on your reference frame. Notice that the sine of F is the same as the cosine of D. This is because cosine literally means complementary sine. And the angle F is complementary to the angle D. Alrighty? So the sine and cosine, this is no coincidence. They were defined this way. This is why in class I say you can really use whatever trig function you want. It's just that not all of them are fast and helpful in particular scenarios. So for example, what if you don't know everything about a triangle? How do the trig functions help you? Here's how they help you. Okay, for example, number 18. Find BC. We did this one in class. Maybe I won't do all of them. Let's start with number 19. A lot of people did this one after me. So we'll do number 19 this time. Find AB. This is our goal. So if I look on the triangle, this is the side I want. AB. I'm going to call it X. Just to keep it in my mind, okay? Now, how in the world do I even begin to approach this problem? All I know is an angle and a side. How am I supposed to solve this function? There's nothing to do. I only know an angle and a side. That's what trigonometry is for. Alrighty, ladies and gentlemen, check this out. Look at this. This is how cool it is. And the beautiful thing about SOHCAHTOA is that it will not only tell us which function to use, it will tell us how to do the problem. So if we write out SOHCAHTOA, and of course you don't have to do it every time, but for me it helps. SOHCAHTOA, I look at the problem and I analyze. Okay, here's the hypotenuse because it's across from the 90-degree angle. It's also the longest side. Okay, here is the adjacent side because this leg of the triangle hugs the 20-degree angle. Alrighty? So since I have an adjacent and hypotenuse side, it seems like cosine would be the best choice to solve this triangle, says Ka. This is because Ka is the only one with an A and an H. Now, again, you could use sine if you really wanted to, but you would have to get this angle, which is 70. Since these angles are complementary, you'd have to get 70, and then you could use the sine if you wanted, right? Again, every path is possible if you follow it diligently enough. So what we'll say, the cosine of 20 degrees, and this is also equal to adjacent over hypotenuse, thanks to Ka, the adjacent, which is x, divided by the hypotenuse, which is 9. Okay? So look, the trigonometric function has given us a proportion that relates this triangle to the ones that we saw in class drawn onto the unit circle. Alrighty? We used similar triangles to get here. So, the value of x is absolute. There's only one possible number. To find it, make a proportion and cross multiply. X times 1 is x equals 9 times cosine of 20 is just 9 times the cosine of 20. Remember that the cosine of 20 it's inhuman to be able to calculate unless you memorize like a table or something. That is the calculator's job. The cosine of 20 is not our job to know. So ensure that your calculator is in degree mode. Alrighty. The cosine of 20 is this number, whatever that means. Remember that this is a ratio of the triangle on the unit circle times 9. And this gives us 8.45. Beautiful. So this length that we want is approximately 8.457 and so forth. Okay, this problem asks us to round our answer to the hundredths place. So as a reminder, the places go like this: tens, hundreds, thousands, and so forth. Okay, so the hundredths place is 2 places, so we'll round up here, 8.46. And I'm going to say approximately for our final answer to be as precise as possible. Beautiful. Ladies and gentlemen, the trig functions were invented solely to make triangles easy. If you are using the trig functions and triangles are hard, then you are not using them correctly. Talk to me. Alrighty? They were designed to make it easy for us, so it should hopefully be pretty easy. Okay? Now, the reason I cross-multiplied here instead of just multiplying both sides by 9, great question. You can absolutely just multiply both sides by 9 here and get the same thing, of course. Alrighty? It's just that sometimes x can be on the denominator, like, for example, in this problem, which we're about to do, and that'll help us then. So let's try the same one. Very similar. We want to find BC. So this is the side we are missing. All right? Notice that this side is opposite, this side is adjacent to the given angle. So tangent is the best choice by TOA. Therefore, the tangent of 30 degrees is equal to the opposite divided by the adjacent. Oh, and actually it worked out to be x on the top. Sorry, I miscalculated there. That's fine. We'll multiply both sides by 2 to get that x is 2 times the tangent of 30 degrees. Okay? Now in the calculator, 2 times the tangent of 30 degrees. Ensuring one more time that I'm in degree mode, I get 1.15. That's my answer. X is approximately 1.15. I went ahead and rounded for us. That took me 15 seconds. Imagine how fast a computer could do this problem. Imagine how fast a well-trained engineer with a big sheet of paper can do this problem. Imagine how useful this is. Guys, I mean, think about the places you see right triangles. Like, I can't even begin to describe. Every bridge ever, bro. Literally every bridge ever has got a triangle on it somewhere. At least 10, maybe 40. Anyways, I'm just being facetious. But, you guys can see how this could be applicable, especially like if you had a computer program that did it for you automatically. You can only imagine the infinite usage of the trigonometric functions. Okay, so let's keep going here. I would like to show some of these. We didn't cover a bunch of these in class, but the principle is the exact same. Okay, so in this case, I'm looking at the problem. Let's see. Now, notice here, I'm actually missing an angle. I want to know the angle of inclination, okay? SOHCAHTOA still works. Oh my God. Oh my God. Please tell me that didn't come through the camera. Holy crap. My stomach just involuntarily groaned. Yes, I'm starving myself to be here. Into the night. It's currently 6:14 p.m. The sun is darkening. The trigonometric problems keep coming. I'm out of options. I just keep doing them, and no one understands. I don't know what to do. So, anyways, guys, for example, now the first thing I notice is this is 4 and this is 8. So this side is exactly twice as long as this side. So it's going to be a weird triangle, right? Anyways, now notice I'm given both the opposite and the adjacent. I'm not solving for a side here. I'm solving for an angle. I'm solving for theta. Fascinating. So I'm going to write out. Now I don't know the angle. So I'm still going to use tangent here. I'm still going to use TOA. Tangent of the angle x is equal to opposite over adjacent. 4 over 8. Ladies and gentlemen, with this treasure I summon, I call upon the tangent inverse function. Look at this. Right above the tangent button in your calculator, if you press second and then tangent, is the beautiful, perfect tangent inverse function. Wow. Oh my gosh, wow. Okay, I think I found out where the microphone is on this. I think it's right here. Tell me how loud this is in the comments. Let me know how loud this is in the comment section. Anyways, so the tangent inverse function, remember, just like any function, if it has an inverse, that inverse has the explicit purpose of undoing the function. So, for example, a tangent of 0.5, okay? I just picked a random number just to show. I'm just picking a random number. It does happen to be the same, okay? But I'm just picking a totally random number here. 0.5 into the tangent function, whatever that is, back into tangent inverse, you get out 0.5. The tangent inverse cancels with tangent. And the great, I don't want to say gods, that feels blasphemous. The great algebraic beings ahead of us have prescribed to us a notion that you could do whatever you want to both sides of the equation as long as you do it to both. So I'm going to do here's like my next step. I'm going to write it really small because I don't want to waste any room here. But I'm taking the tangent inverse of the tangent of x. The tangent inverse of the tangent of x is equal to, and I'm going to do the same thing to the other side. I'm leaking over here, but that's fine. Tangent inverse of 4 over 8. Alrighty? So tangent inverse and tangent cancel, and x is equal to the tangent inverse of 4 over 8. Sometimes you may hear, if you go to watch YouTube videos about this, if this confuses you, just be aware. Some other schools in other parts of the United States call this arctangent. Okay, it means the exact same thing. Arctan is equal to tangent inverse. Alrighty, they are the same thing. They do the same thing. They are exactly the same. They just have different names. So just keep that in mind. You may see that if you travel elsewhere. Anyways, so in the calculator, we'll ask the calculator, well, what is the tangent inverse of 4 out of 8? The calculator says it is 26.56 degrees. How quaint. 26.56 degrees. I'm literally starving, so I have to get up at some point and leave. Anyways, what we're going to do here, if you guys see, this is the answer. It's the exact same for these other problems. You do the exact same thing. This one looks like a sine. This is a cosine. And you do the same principles. You use the cosine inverse or sine inverse, depending on what, suits you best. You set up a proportion, and you solve for x. It's all the same. So, I'm yelling so you don't hear my stomach again. From a point that is, I'm going to try one of these just to show how I would do these, okay? This is technically 5e, but really it's just 5d, which is trig all over again. From a point 80 meters from the base of a tower, the angle of elevation to the top of the tower is 28 degrees. How tall is the tower? How tall is the tower? Oh my God, imagine how useful this is, okay? Let's say there's a tall tower. How tall do we think? I'm going to draw it like relatively tall. My intuition from the numbers, tells me this is like, I don't know. I'm gonna guess like 20 to 30 meters. Okay, so I'm thinking it's somewhere in this range. What's 20 to 30 meters? Let's see, 60-ish feet tall. It's like a big power pole, like a tall telephone pole or something. Alrighty. So here's my telephone pole. Doesn't have me. It could be any. That is horrible, Lord. Anyways, we want the height of this tower. So here's the height, okay? And we're at a point which is 80 meters away from the base of the tower. So here's the point. Here is the triangle. We want to know the height of this tower. So I'm going to call it h. We are 80 meters away. And the angle of elevation to the top of the tower is 28 degrees, okay? So, notice what this says. This says to the angle of elevation to the top of the tower. Recall that an angle of elevation or inclination starts at the horizon, then goes up. Just like we did with in honors, we did this with the plumb bob. Let's see if I can draw a little picture. Remember we had the protractor, we hung the string from it with a crayon, and then we pointed it at stuff. Okay? And then remember, we tilted up to look up. Obviously, if you tilt down, you look down. So, in any case, that's this angle, which we said to be 28 degrees. How lovely. Now, I see that this is a tangent problem. There's an opposite side. I want the opposite. I have the adjacent. So, I know that the tangent of 28 degrees is equal to, and here we have opposite over adjacent, which is h over 80. So the height here, I'm going to write like an arrow. My handwriting is also fading because I'm starving so much. Oh my gosh. I have 80 times the tangent of 28 degrees. And for our final answer, we get 42 feet. Wow, I was a little bit off there. 42.53 feet. Oh, sorry, this is in meters. Sorry, guys, this is in meters. Alrighty? So it is a good idea to keep your units attached, all right? Let's see. I think I'm going to leave these other ones as challenges for you guys. Of course, there will be a key online. You can check your answers. Alrighty? But Try and do these on your own. I will not be there for you all the time. What will you do when the problems you face are harder than math problems? Okay? What will you do? Ladies and gentlemen, that is all I got. I'm going to go home and eat. All right. Let's see. I can't remember what the meme was here. I was supposed to say something funny, but I forgot. So I'm just going to have to leave you guys with a good classic, I don't know. Let's see. Well, what's a good meme? Peace out, twin.